Ever wonder how a compass knows where north is? Or how lightning flashes across miles of sky? What about that weird shock you get from a doorknob? Or how your phone charges without a cable? These aren't magic. They're all thanks to an invisible force, a fundamental concept that underpins our entire technological world: the field. For centuries, thinkers were baffled. How could the Earth pull an apple down without touching it? How could two magnets push or pull each other from a distance? This was the perplexing problem of action at a distance. It felt almost supernatural. We understand direct contact. I push a box and it moves. Simple. But gravity, magnetism, and electricity seem to defy this logic. Until a revolutionary idea emerged, an idea that transformed physics forever. Our journey begins with electricity. More than 2,000 years ago, the ancient Greek philosopher Thales of Miletus noticed that rubbing amber with cloth allowed it to attract tiny pieces of straw and feathers. It was one of humanity's first observations of static electricity. Fast forward to the 18th century, and Benjamin Franklin, with his famous kite experiment, demonstrated that lightning was electrical in nature. He also introduced the ideas of positive and negative electric charge. We now know that opposite charges attract, while like charges repel. But one question remained. How does one charge know another charge is even there? Charles Augustin de Coulomb answered part of that question. His famous law tells us that the electric force between two charges depends on the size of the charges and decreases with the square of the distance between them. Double the distance, and the force becomes 4 times weaker. Coulomb's law accurately predicts the strength of the interaction, but it still leaves one mystery unsolved. How is the force actually transmitted through empty space? That question led to